Hi guys, today I'm going to be doing a video for Maths GCSE revision on highest common factor and lowest common multiple. I'll talk you guys through the key concepts and I'll go through some practice questions to help you be able to fully understand this topic in more detail, ready for the exam. So firstly, before we talk about HCF and LCM, we first need to understand how to go about finding a number as a product of its prime factors. My preferred method to do this is a tree diagram, but there are other methods. I've seen ladder methods, but I'll show you how to do a tree diagram, as that's how I was always taught. So question number 1 is express 30 as a product of its prime factors. So we start off writing 30, and then I always try to find the lowest prime number that will go into it. So in this case it's 2. And then I put a circle around 2, just to remember that it's a prime number. And then 30 divided by 2 is 15, so 15 goes here. The lowest prime number I can think of that goes into 15 is 3, and 3 goes into 15 5 times, which is also a prime number actually. So that means 30 expressed as a product of its prime factors is 2 times 3 times 5. So let's try another one now. Express 136 as a product of its prime factors. So nothing changes, we go about it the same way, it's just going to be a slightly longer process. So 136, 2 goes into that. If it's even, 2 will always go into it. And that goes into 136 68 times, I think. 2 also goes in 68, so circle that. And that goes in 34 times. 2 goes into 34 as well. That goes in 17 times, which is also a prime number, a slightly bigger one. So that means 136 expressed as a product of its prime factors is 2 times 2 times 2 times 17. Or we could shorten that by just writing 2 cubed times 17. So the final one I have here is express 1080 as a product of its prime factors. Now I'm probably going to need quite a lot of room to do this one, but we'll give it a go. 1080 definitely divides by 2, which goes in 540 times. That divides by 2 as well, which goes in 270 times. That divides by 2 as well. 135. Let's just give ourselves a bit more room here. And I think 3 goes into 135. Goes in 45 times, I think. 3 goes into 45 again. 15, and then 15 is 3 times 5. So 1080 expressed as a product of its prime factors would be 2 times 2 times 2 times 3 times 3 times 3 times 5. Or a shorthand way of writing it would be 2 cubed times 3 cubed times 5. Okay, so hopefully you guys are sort of getting the hang of how to do a tree diagram now. We're going to move on to the LCM, or the lowest common multiple. So the lowest common multiple is the smallest number that will divide by all the numbers in question. So if I can explain this, for example, if we had 18 and 30. 18 is 2 times 3 times 3, and 30 is 2 times 3 times 5. And these are the prime factors. So if a prime factor, find and list all the prime factors of the numbers provided in the question. Sorry, I forgot to say that. So we've listed the prime factors. Now, if a prime factor of one number appears once, so for example, here in 30, 3 only appears once, and in another number appears more than once, in 18, 3 appears twice, we would always take the higher power. So when we come to this stage, stage 3, multiply prime factors together, you would end up with 2 times 3 squared, though, because you always take the higher power, times 5. And then that would give you an LCM, so LCM equals, will give you an LCM of 90. So now we move on to the HCF, or the highest common factor. It's defined as the biggest number that will divide into the numbers in question. So the largest factor that divides into both numbers, basically. So there's only 2 steps for HCF, so it might be a bit easier. Find and list all the prime factors that all of the numbers in the question have in common. So for example, if we take 18 and 30 again, we know 18 equals 2 times 3 times 3, 30 equals. So, and then you find all the ones that they have in common. So quite simply, you could even do this by drawing a little Venn diagram. So we've got, they both have a 2, they both have a 3, so this one's 18, this one can be 30. So 18 has an extra 3, and then 30 has an extra 5. So the two that are in common are 18 union 30, if you like, 2 and 3. So the HCF is literally, you take 2 and 3, the ones they have in common, equals 2 times 3, which equals 6. Okay, so now let's move on to some questions, like you might get in an exam. So number 1, find the LCM of 14 and 36. So first let's start off by listing each 14 and 36 as product of prime factors. So 14 is quite easy. I think it's just 2 times 7. And 36 is 2 times 2 times 3 times 3, which equals 2 squared times 3 squared. So if we want to find the LCM, we want to take all the numbers in both and then take them to the highest power. So we have 2s, 3s, and 7. So it's going to be 2 times 3 times 7 LCM. But then we take it to the highest power. So 36 has 2 squared, so we use the higher power. It also has 3 squared, so we use the higher power. And so you get 2 squared times 3 squared times 7. So that LCM equals 252. That is the lowest number that both 14 and 36 is the lowest multiple that they have in common. So question number 2, find the HCF of 90 and 135. So again, we start off by finding the product of each has a product of their prime factors. So 90 is 2 times 45, and then 45 is 3 times 15, 15 is 3 times 5. So 90 equals 2 times 3 squared times 5. And then we have 135, which divides by 3 to give us 45, which divides by 3 again to give us 15, which divides by 3 again, lots of 3's in this one, to give us 5, which is another prime number. So 135 equals 3 cubed. You know what, I'll just rub that out and write it again. Why is the eraser not working? Oh well, we know it's 3. So 3 cubed times 5. So if we want HCF, we want the highest common factor. So the number is going to be less than 90, most likely. Well, it is going to be less than 90. So we take all the numbers they have in common. So for this, it's actually easier to write it as 2 times 3 times 3 times 5. And then to write this one as 3 times 3 times 3 times 5. Then you find what they have in common. So they both have 2 3's and a 5. 2 3's and a 5. So the HCF equals 3 squared times 5, which actually equals 45. So if you wanted, you could check by going to a calculator and saying, does 90 divide by 45? Yes. Does 135 divide by 45? Yes. So in theory, it all works out. So question number 3 is a bit longer. It says, given that 18 equals 2 times 3 times 3, 84 equals 2 times 2 times 3 times 7, and 150 equals 2 times 3 times 5 times 5. Find the HCF and LCM of 18, 84, and 150. So basically, they've done half the job for us. They've already given us the prime factors. Now what I'm going to do is write next to them here what they would be in the shorthand way of writing it. So this would be 2 times 3 squared. This would be 2 squared times 3 times 7. And 150 would be 2 times 3 times 5 squared. Because it's actually easier to, when you're working out the HCF, to use these ones, but when you're working out the LCM, it's often easier to write it like this because you can see the higher powers more easily. And also this question is going to be a bit harder because you've got 3 numbers. Well, it won't be harder, but it'll be a bit more work. So let's start off by finding the LCM. So the LCM, lowest common multiple of all of them, we take all the numbers present in their highest powers. So you take the highest power of 2 is 2 squared, the highest power of 3 is 3 squared, and then we also have a 5 squared, and then we also have a 7. And even though the others don't have 7, you could think of them as being, for example, you could think times 5 to the 0 times 7 to the 0, because anything to the 0 is just 1. If you know from your indices, x to the 0 always equals 1. So anyway, back to LCM. This would equal, let me just do a quick calculation. So 2 times 2 times 3 times 3. Sorry, I have a bit of a basic calculator, so it takes a while. Oh no, it's made a mistake. 2 times 2 times 3 times 3 times 5 times 5 times 7 equals 6,300. So that's actually quite high, higher than I was expecting, but we have gone about our business correctly here, so it must be correct. So next on to the HCF, or the highest common factor. So HCF is the highest common factor. If we use these numbers here to see what they all have in common, they all have a 2, so let's cross out the 2's. They all have a 3 as well, and I think that's it. So the highest common factor is just 2 times 3, which equals 6. So yeah, wasn't too tricky, but hopefully you guys are feeling a bit better about these questions now. So now we've got some more wordy questions. So we have Marcus and Sam are brothers. That's weird, should say brothers. Let me just fix that. Marcus and Sam are brothers. Marcus travels to London every 3 weeks, and Sam travels to London every 8 weeks. They both met up in London today. How many days until they are next in London on the same day? So firstly, it's asking you for how many days. So I would change these weeks into days. So we know that 3 weeks equals 21 days, and 8 weeks equals 8 times 7, 56 days. So if we find these numbers as product of their prime, 21 is literally 3 times 7, and 56 is 2 goes in 28 times, another 2, 14, and then 2 and 7. So 56 as product of its prime is 2 squared times 7, which we can also write as 2 times 2 times 7. So now, to find the lowest, it's asking us how many days until they next are in London on the same day. So it's effectively a wordy way of asking us for the lowest common multiple. So we'll write here LCM equals, and using our superior knowledge that we have gained so far, we know that we take the highest power of each number present. By the way, this should be 2 cubed, not 2 squared. So add another times 2 in here. Sorry, I missed that. Using our knowledge, we know that we take the highest power, so it would be 2 cubed times 3 times 7, which equals, let's just do a quick calculation again, 2 times 2 times 2 times 3 times 7 equals 168 days. So 168 days until they can next meet up, have a coffee, do whatever brothers do in London, which I believe that is 24 weeks. It was quite a long time, nearly half a year, till they can meet up again. Hope they find some other time to meet up, because twice a year is not very often. But anyway, moving swiftly on, we've got another wordy question about donuts, it appears. Katie wants to sell some donuts. She has 50 jam donuts and 30 custard donuts. Oh, it's making me hungry just thinking about that. She wants to sell the same number and type of donuts in each box. What is the maximum number of donuts she can sell in each box? Now, first impressions, I'm thinking this is an HCF question, but it doesn't seem like it's going to be that straightforward, because I think if you get the HCF, you'll find the number of boxes that she can make, not the number of donuts she can sell in each box. So we know the total number of donuts she has is 80 donuts, so total donuts equals 80. So if we split them up into their prime factors, 50 jam donuts is 2 times 25, which is 5, we can put times 5 times 5. So 50 equals 2 times 5 squared. Well, actually, you know what, I'll write it as well, because this is an HCF question. 2 times 5 times 5. And then we have 30 custard donuts, so 2 goes in 15 times. 3 is the next lowest prime number, that goes in 5 times, so 30 equals 2 times 3 times 5. So HCF will give us the number of boxes that she can sell. So if she wants to have the same number and type of donuts in each box, she can sell, if we look what they have in common, there's a 2 in both, and there's a 5 in both, so it's 2 times 5, which equals 10 boxes to sell. Now if she has 80 donuts, that means she's going to sell 80 over 10, 8 donuts, keep feeling the M, per box. And we could go a step further and say, so in each box she'll have 5 jam plus 3 custard. And because everybody likes a good donut, she'll probably make a killer profit. Anyway, thanks for watching, guys. If you have found this video useful, please subscribe to the channel. I'll hopefully get some more GCSE Maths revision videos out soon. So thanks for watching. See you soon. Bye.